Hi students, today we are going to continue working in My Math chapter 9, looking at lesson 10, using models to add mixed numbers. Students will be able to explore adding mixed numbers using models. So today we are really exploring this new idea of adding and then subtracting mixed numbers. So we're going to be drawing and using models today, and hopefully that helps us to visualize and understand what we're doing before I teach you the exact steps. All right, so if you use the fraction strips from Toy Theater that I've linked many times during class, feel free to have that out and open to learn that and practice this skill as well. All right, so modeling mixed number sums. We're going to focus right now on adding and modeling mixed number sums. So recall that a mixed number is a combination of at least one whole and a fractional part. Okay, so a mixed number could be something like 2 and 1/3. So we read this as 2 and 1/3. This means we have two wholes and then another third of something. So you could think of this as in time, like the number of hours. You watched a movie that was 2 hours and then another third of an hour, which is 20 minutes. You could think about this as measurement. 2 whole feet and a third of another foot. Okay? You can think of this like your age. A young child might be 2 years and a third, meaning 2 full years old and then a third of another year. That's what mixed numbers mean. So in our first problem, we are going to take 2 and 1/3 and add to it 1 and 1/3. All right, so if you use the fraction strips, we could, of course, model this with them. So I can take 2 wholes, 1, 2, and 1/3. So 2 wholes and a third. And I'm adding to that 1 and 1/3. I'm adding to that another whole and a third. Now I kind of have them all over the place. Let's see if I can arrange these so that my fractions are together and my wholes are together. I'm going to put both of those fractions down here, and I'm going to put the whole up here. Now I'm more organized. I notice that my two fractional amounts, and let's just go back, 1/3 and 1/3, they're the same size pieces, they're the same color tile because they have the same denominator. That makes things nice. That means I can just count them and say I have 2 of the thirds pieces. That's fantastic. So when I'm answering this question, I know that my fractional amount will be 1/3 plus another third. And 1/3 plus 1/3, as I saw, gave me 2/3 in my model. But we're not done because we had some wholes. Our first mixed number had the whole amount 2, shown with those 2 pink ones. Then in my second mixed number, I added one more whole. And now you can see I have a total of 1, 2, 3 wholes. So when I go back for my answer, 2 wholes plus one more whole gives me 3 wholes. So my sum is 3 and 2/3. And let's go back here. I have 3 wholes and 2/3. Let's do another one. For this next problem, we're not going to have a common denominator, which just makes things a little trickier. So I have 1 and 7/8 plus 1 and 1/2. Now I'm going to model this for you. Okay, so here is my next question. What's 1 and 7/8 plus 1 and 1/2? Let's model each of those mixed numbers. 1 and 7/8. All right, 7/8. These are the blue ones. 1, 2, get up there. 2, 3, 4, 5, 6, and 7. So there's the first mixed number, 1 7/8. And I'm adding to that 1 1/2. 1 1/2. Here's 1 whole, and we can put it anywhere. Here's a half. Now I want to rearrange these and organize them. I'm going to put my wholes next to each other. Why not? And then I have these fractions, and now I notice something. I notice that my fractions are different sizes and different colors because they have a different denominator. I have these blue eighths that are smaller pieces, and then I have a larger 1/2 piece. Well, that means I have to do some trading. Okay, we have to figure out how to rewrite one of these or both of these so that they're all the same. Now, I could trade 4 of these eighths for a half. Look at that. Notice 4 of these eighths pieces are the same as a half. So let's do that. I'm going to get rid of 4 eighths, and I'm going to put up a half. Here's my half. Get rid of 4 eighths. 1, 2, 3, 4. Same amount of space. Same amount of space. Okay, so now I have 2 beautiful wholes. I have 2 halves, and then I have 3 eighths. So wait a minute. When I put these 2 halves together, it looks like it gives me 1 whole, and that's because 2 halves equal a whole. So we can do another trade. I'm going to trade 1 whole and get rid of those 2 halves. Same amount of space. And then I notice I have these 3 eighths left. I'm going to put that over there. Can I simplify those 3 eighths anymore? Does anything equal 3 eighths? Not that. Not that. 2 of those won't work. Nope, 3 eighths is simplified. Okay. So what did I do for this model? I had to do some trading in to make a common denominator. Remember, we can't add fractions unless they're the same fraction strip color and size because of the same denominator. So what did I get? I have 3 eighths and I have 1, 2, 3 wholes. So I got a sum of 3 3 eighths. Now you might look at this and say, well, what? We're adding 1 and 1. Why are we getting 3? Well, that's because, remember when I combined my fractions, we ended up making another whole. And that's because if you add 7 eighths and another half, it's more than a whole. And that's why we bumped up to a 3. Let's do one more modeling example. And I am looking for one in my book that is a good one. Let's do 1 3/5 plus 1 4/5. Okay? So for this example, we have a common denominator. Sweet. All right, but let's just model these. I need 1 whole and 3/5. So let's take 1 whole and 3/5. Now you can really put them anywhere because we're going to organize them. So you could put the 3/5 down here or over here. It really doesn't matter. Here is 1 whole and 3/5. Now what are we adding to that? Another whole and 4/5. So add another whole and 4/5. 1/5, 2/5, 3/5, 4/5. Okay. So now we could say that we have 1, 2, 3, 4, 5, 6, 7/5, and then 2 wholes. I'm going to write that down. 2 wholes and 7/5. Does that look a little funny to you? It might, because this numerator is greater than the denominator. That means that 7/5 has a whole hiding in there. All right, let's see. I need another, can I make another whole? Looks like I can. It looks like if I add 1 more fifth, I get a whole. You see how that worked? Now I have another whole. So I'm going to keep this whole and get rid of those 5/5 because they equaled a whole. All right. So what do I have left? I have 2/5 and 3 wholes. I have 2/5 and 3 wholes. Now, this one I didn't have to trade too many times. I had a common denominator. So when I traded, it was just to kind of regroup. So for this question, again, 1 plus 1 equals 2, but notice we get 3. And we get 3 because these two fractions equal more than 1 whole. So we had to carry over. All right, the next video will show you how to find mixed number sums and differences without the models. I'll teach you the steps. Thanks for watching. See you next time.